All right, let's take a look at outliers for five number summaries. Let's take a look at outliers for quartile data. Um, I'll run you through some basic definitions first, and then we'll get right to the bottom line, which is actually up front, the criteria to identify possible outliers for quartile data. So quartile data has a five number summary, four parts. So there's five dividers, the end and the beginning. That's why there's five dividers. The numbers are the dividers. The quartiles are um, I don't know, the areas between, the range of numbers in between. So we could visualize this idea of minimum, quartile one, median, quartile three, and maximum. That's when we do, right, we do a whisker for this part, and then this part's a box, and the median is that straight line between the two boxes. The third quartile is the next box, sorry for the mess, and then the final bit up to the maximum is the whisker, right? Box and whisker. Um, that diagram is not to scale at all. I'd need the x-axis labeled, and we'd need to find out, to visualize it, we need to see how wide or narrow each part is. So I just wanted to remind you how the box and whisker relates to the five number summary, right? You saw the four quartiles, end and beginning, right? That makes uh, quartile 0 and quartile 4. Quartile 1 and 3 is the boundary between the boxes and the whiskers, and then the median right in the middle, the fifth number, so to speak, is halfway through. So range, the range is just the full range from maximum to minimum. It is not a very good measure of spread. In fact, some textbooks don't even call it a measure of spread. They just call it the range. Um, it's a very bad measure because you're going from extreme to extreme. It does not give you a good picture of um, the size, right? Remember, spread for mean and standard deviation gives you an idea of how widely spread the data is. Max minus min, I'm also going to remind you that max minus min is the same as quartile 4, right? That's the 100% mark. Everything is below the 100% mark. Minus quartile 0, right? Quartile 0 is 0% of the data is below that mark, right? The minimum. The IQR is much more useful because it does give you a feeling for center, all right? The definition is Q3 minus Q1, right? See how instead of the extremes, Q4 and Q0, the min and the max, we go one in. I'll draw a diagram now, right? Again, not to scale. I'm not trying to pretend to be the numbers above. This is just the general idea for IQR, interquartile range, right? That's the max. That was the Q4. And the full range, a very bad measure of spread, is from Q4 to Q0. But the nice thing is, if you pick Q3 over here, right? Q3 is the 75th percentile. And Q1 over here, that's the 25th percentile, right? 25th to 75th, that's 50%, right? So you've got half of the data, but you've got the middle half. The middle half of the data gives you a sense for how widely spread the middle part is, right? That's much more like the bell curve of the mean and the standard deviation where you kind of measure out from the center bit by bit by bit. So the center 50% is what defines our good spread. That's the measure of spread for quartile data, the interquartile range. And if you ever get confused, just think of it, it's really the inter-middle quartile range, right? This is this quartile 25%, that quartile 25%, the middle 50%. How wide is that? That's what IQR measures. So for this problem, right, let's just get the numbers done. For this particular problem, um, the IQR, you're looking at it right up there. It's not a big deal. You might have to do it from, I don't know, maybe a picture of a box and whisker plot, right? Why don't you just find Q1 and Q3, those boundaries, and you look on the graph to see what their values are, and you find the difference. That's the interquartile range. So for this problem, it's 120 minus 95. Get your calculator if you're not great at triple and double digit subtraction. It gives you a 25. All right. That's the measure of spread. That's a good measure of spread. The median is 110. The good spread for this data is 25. So now you have a feel for how widely the data is spread out. And you start getting a feel for whether those minimums, maximums are extremes. The criteria is exact. The criteria is take 1.5 times that IQR, right? You don't have a choice on this. This isn't subjective. It is multiply by 1.5, right? So 1.5 IQR, that gives you 37.5. And now you know the number that you have to add and subtract. But remember, it's not from the center, not from the center, right? You already got that measure of center by taking Q3 minus Q1, right? Q3 minus Q1 gave you the spread. What you have to do is go 1.5 times wider than Q3 minus Q1. So you have to go, right? About the same and then half more, right? The same as Q3 minus Q1, the IQR, and then half more. Anything lower will be considered an outlier. Anything higher will be considered an outlier. That's why we have these two formulas up here, Q1 minus 1.5 IQRs and Q3 plus 1.5 IQRs. In this problem, right, we know Q1 is 95. We know our 1.5 IQRs is 37.5. So again, pull out the calculator and you get the low end, right? The low mark here is 95 minus 37.5. That should give you, I believe it's 58, 57.5. Yeah, 57.5. Pull out your calculator. I'm doing it in my head just to go faster, especially when there's decimals involved. And then, we got to do this one also, right? What's that upper range? Well, that's Q3 plus the 1.5 IQR. Q3 we know is 120. So we add 37.5 to 120 and we get 157.5. All right, so now we can answer the final question. Do we have any outliers? Right? Let's take a look. Let's be careful. We have to be below the 57.5 or above the 157.5. And we do indeed have the minimum smaller right? It's just a little bit beyond that extreme marker. However, the maximum is 155. It's within that 1.5, just inside, right? Just inside. These differences can be subtle. We do know 55 is pretty far from 110, the middle. We know 155 is pretty far from 110, the middle. So we can't really just kind of eyeball it. We need this criterion. So according to this criterion, only the minimum could be classified as an outlier. Largest? No. Too small. It didn't break out. Nope. Smallest? Yes. Yes. It did break outside um, that rule. Take a look at the diagram. It's almost like what you're doing here is you're ignoring the actual whiskers and you're kind of setting an ideal. What would how long could the whiskers be and it not be considered outliers? That's what you're doing. You're just paying attention to the middle, right? Measure of spread. You look in the middle. So you look in the middle, find out how wide that is, add 1.5 times to the right, 1.5 times to the left. That's really all I have to tell you, but I will give you one extra insight. If you don't want to listen, it's okay. What I always like doing is saying, look, I want to know where that 1.5 came from. Why is this blue line 1.5 when we add it to Q3, right? What's going on here? Why is that 1.5 and not 2 or half or whatever? I don't know exactly, but if we assume that the interior boxes here are fairly symmetric, if we assume Q1 and Q3 are about the same size, then right, the whole box is 1 IQR, so this is 0.5 IQRs, right? If I measure, right, assuming the median is close to exactly in between Q1 and Q3. Remember, that's not true in real data. 15 in that direction, 10 in that direction, there's asymmetry. We use box and whisker plots, we use quartiles when there is asymmetry. But let's pretend it was a little more symmetric. Look at that. You have 0.5 from the center, and then you add 1.5 more. So you're kind of 2 lengths, 2 IQRs from the center. That's not a formula. That's only how things feel when there's lots of symmetry. I hope 2 IQRs from the median kind of reminds you of 2 standard deviations from the mean. Remember when we analyzed those rules of thumb for bell curves, and we knew that 2 standard deviations from the mean was 95% of the data is within it. So it's the extreme 5% that's on the outside, 2.5 each side for a bell curve. I think that's what's going on here. We're finding the spread, and we're kind of going around 2 spreads, IQRs, from the center. So there's a certain parallelism between this formula and the idea that, 5% outsiders, right? The 5% outsiders, the 95% insiders. In social sciences, psychology, educational research, usually we do pick 2 standard deviations from the mean. Anything within that range is considered normal, and it's the outside that's considered outliers. Something interesting is happening. Same thing here. So don't remember any of that in terms of formula, just remember it in terms of there's some underlying structural similarities. Memorize these rules. How to find the IQR, take 1.5 times it, and then add it and subtract it to the edges of the box that define the IQR, right? It refers back to itself.